Alright, so today we're going to talk about congruent triangles.
Hooray.
Hooray! Our new unit. We finally get to look at shapes, so that's exciting. Good times. Yay, shapes. We're going to look at triangles for a long time. We'll be looking at triangles till like February.
Hooray. I love triangles.
Good. There's so much to learn about a triangle. Some of it we already know. Most of what we're going to do today, we already know. So today is mostly review, hence it says classifying triangles. Review. We've already talked about that there's 6 things to measure on a triangle. Do you remember what they are? You measure one with this, and you measure you measure 3 of the things you can measure with this, and you measure 3 of the things you can measure with this. Sides and angles, right? So when we classify triangles, triangles can be classified in 2 different ways. They can be classified by their sides, and they can be classified by their angles. They can be classified by their sides and by their angles. Okay? So this chart here, this first one, is classifying triangles by its sides. And this is not new to you. You have seen this before. When you're classifying by the sides, there are 3 options. There is scalene, which means none of your sides are the same. No congruent sides. There's isosceles, which means at least 2 of your sides are the same. And then there's equilateral, which means all of your sides are the same. Okay. Equilateral. Lateral means like side, right? Your sides. All right, so remember that the short lines, the little tick marks, can be used to show you that you have congruent sides. So that's how I know all 3 of these are the same. They have those little short lines on them. That's how I know these 2 are the same. They have the little short lines on them. Okay? An equilateral triangle, because of the definition of isosceles, your equilateral triangle is technically an isosceles triangle because it does have at least 2 congruent sides. Okay? But super important to keep in mind when asked to give the best classification, use the most descriptive. Okay? So in other words, if I give you an equilateral triangle, all the sides are the same, and I ask you to classify it by its sides, if you tell me isosceles, that's a correct answer. If you tell me equilateral, that's a correct answer. You're both correct, whoever says whichever. But if I say give the best classification for this triangle, then you have to tell me equilateral, because equilateral is more specific than the isosceles. Equilateral says not only are at least 2 of my sides the same, but all of my sides are the same, right? So it's the more descriptive. So if a triangle is equilateral and it asks me for the best description, I don't even say isosceles. I just say equilateral. Okay? Let's talk about angles. When we classify triangle by using angles, so that's my second table. Classify triangle with angles. So we have acute, right, and obtuse. We don't have we added on straight to our angle measurements, right? There's acute angles, there's right angles, there's obtuse angles, there's straight angles, and then there's reflex angles. But we don't have straight triangles, that wouldn't work out, and we don't have reflex triangles. We just have acute, right, and obtuse. The interesting thing here is that if you notice on your acute triangle, all 3 angles are acute. All the angles are acute. Okay? In my right triangle, it says I have 1 right angle. I'm not going to have all 3 right angles or 2 right angles. I just need, if you have 1 right angle in a triangle, it's a right triangle. Okay? To be acute, all 3 have to be acute. Okay? similarly to the right triangle is the obtuse triangle, you just need one obtuse angle. Okay? The other two can be right or can be acute. You only need one obtuse angle and then you call it an obtuse triangle. Okay? New vocabulary word not on our table. An angle with, it should say a triangle, with 3 equal angles is called equiangular. So what that's going to look like is all 3 of the angles will have the same measurement. So remember, to show that angles are the same, we're going to have arc marks that are the same, and that shows me all 3 of those angles are the same. That triangle is classified equiangular. Okay? So this triangle, if I asked you to classify it by its angles, those angles may all be acute. So technically, it's an acute triangle. So if I just say, classify this triangle, and you call it acute, that's not wrong. If I say, classify this triangle, and you say equiangular, that's not wrong. If I ask you to give the best classification, and you say acute, is that okay? No. What's going to be the best classification for this? Equiangular. Okay? Equiangular. You only ever give one classification, so you have to pick out of the 4 which one of those 4 is the best. Up here you have to pick out of the 3 which one of the 3 is the best. Okay? So you pick one from here and you pick one from here. When you classify a triangle, you should be classifying it how many different ways? 2, right? You're going to classify it by its sides, you're going to classify it by its angles. So a triangle could be an acute scalene triangle. A triangle could be a right scalene triangle. A triangle could be a right isosceles triangle. A triangle could be an equilateral equiangular triangle. Okay? So you always have both. You have one from here and you have one from here. Every triangle gets 2 classifications. Okay? Sometimes when we're asked to give the classification, we don't have enough information. And so we can only for sure know what one of the classification is, and then you can't give me the other one. Okay? And we'll look at an example of that. Alright, so again, anytime you're asked to classify triangles, unless they specify classify by sides or classify by angles, if you have enough information to do both, you should give me both of those classifications. And then remember, always, if it asks for the best classification, always give the best classification. Okay? Let's look at these 2 examples. It says classify the triangles below using angles and sides. It doesn't say best classification, so if one of these were equilateral or equiangular, I could use the other descriptor. And then it says circle the angle and side names. Pictures are to scale. This part's going to become real important. When you see these pictures are to scale, what that means is I can measure the triangle. This triangle is exactly what it looks like. Okay, it's not one of those things. Remember, sometimes we draw lines and the obtuse angle when we do the math turns out to actually be an acute angle. So it's not going to be like that. If it says the picture is to scale, then you can assume that you can go back and you can actually use a protractor on it. You can actually use a ruler on it. Okay, but it has to tell you that the picture is to scale. If it doesn't say picture to scale, you can't measure it. You can't use your eyeballs and say, well, that looks like a right angle. Okay? Unless it says picture is to scale, or for a right angle, it would have to have the little box in the corner, right? All right, so let's look at this first one. Remember, we're going to classify it how many ways? 2. So you're going to circle 2 things. All right, what kind of triangle do I have here? Isosceles. That's how I remember how to spell it. Good. Isosceles. What kind of how did you know there were? I didn't even measure anything. How did we know 2 sides were the same? 2 tick marks. Should we check to make sure it's not equilateral, that they just didn't put a tick mark on there, but that one's actually equal? Since it's to scale, I could measure it. Okay, so I could come here and I could measure it. That one's what? 2.2. So let's see, is the one on the bottom 2.2? No, it's not even 1.5. I always measure in centimeters because to me centimeters are just way easier than inches. Because these, do you know how big each one of these little tick marks is? It's not 0.1, 0.2, 0.3, 0.4. They're fractions. So that's 1/16, 2/16, 3/16, 4/16, right? Because 4/16 is 1/4. So that's 0.25, 1/4. But all those ones that aren't 1/4 or 1/2 or 3/4, the 0.25, the 0.5, and the 0.75, all of those in between those are like those 16th fractions, and those are no fun to work with. Okay? So I always use the centimeter side just because it's easy, because it's 0.1, 0.2, 0.3, 0.4, right? If it's right in the middle, you can say point whatever number 5. Okay? All right, so it is isosceles, but we need to circle another one. What's the other one?
Acute.
Acute. Should we measure it just to make sure? So remember, when you line up with the bottom, this right here in the center is your 90 degrees. So if it fills in more than one side, either side, then it's obtuse, right? If it goes right to the 90, it's right, and if it doesn't fill up a whole side, then it's acute. So this angle on this side doesn't fill up, it's acute. The angle over here on this side doesn't go past the 90, it's acute. And the angle up at the top, that angle doesn't go past 90, it's acute. So yay, it is acute. All right. My next triangle, what is it?
Right angle.
It's a right triangle because it has one right angle. It only has to have one. Once you got one, you're a right angle or right triangle. What about its other classifications?
Scaling.
Scalene. Should we measure it just to make sure?
Yeah.
Okay. How long is this side? 2. About. How long is this side?
1.
I don't know, but not even close to 2, right? How long is this side?
3.5.
Yeah, way bigger than 2, right? So one's right at 2, one's way under 2, and one's way bigger than 2. So they are all different. This is scaling. Okay? So again, the next is just talking about how you say it out loud. If I'm ever asked you to say it out loud or write it in a sentence, you give both descriptors. This is a right scaling triangle. Okay? Or you could call it, this is a scaling right triangle. Doesn't matter which order you put them in because they're just description words. It's kind of like if you said the cute barking puppy or the barking cute puppy. Doesn't matter if you put cute or barking first, it's still the same puppy. Because all puppies are cute.
Yeah.
I mean, I think so.
I prefer cats.
But that doesn't mean puppies aren't cute. I mean, I have 3 cats. I don't have any puppies. But when I see a puppy, I get excited.
Cats are just better like them.
If somebody walked in here with a puppy or a baby, I'd be much more excited about the puppy.
Are you ready to see Miss Harlow's baby?
I am. I did see a picture. It's really cute. But again, if she walked in with a baby and somebody else walked in with a puppy, I'd be way more excited about
Who would be cuter than
the puppy.
the baby?
The puppy.
The puppy would be cuter than the baby?
What about the baby turtle?
There's a reason I made it to 45 years old and never had kids. Because puppies are cuter than babies. And you can put a puppy in a kennel. And cats, they're even better. You don't even have to put them in a kennel, and they have their own little bathroom that they just figure out how to use. Great. All right. What about this triangle here?
Isosceles.
Isosceles obtuse. How do you know it? I know it's isosceles. How do I know it's isosceles?
The tick marks.
The tick marks. Okay. How do I know it's obtuse?
Because it doesn't have the square.
But that doesn't mean it's obtuse.
We can.
The angle is bigger.
Because the angle is bigger than 90. If I put this here, it fills up more than one side.
Yeah.
It goes past the side. But wait, this is a new section of my notes. Does it tell me in this section that these pictures are to scale?
Negative.
So am I allowed to use a protractor in my eyeballs?
No.
Guess what that means? If I don't know this picture is to scale, I can't trust anything that Miss Bishop ever gives me unless she tells me it's to scale.
Oh my god.
I know, it's sad. You'd think you could trust your teacher, but you can't. Just because that looks obtuse, we've seen where I've drawn pictures, right? And we've done the math, and then the acute little angle has turned out to really be an obtuse angle, or vice versa. So just because it looks obtuse, if it doesn't tell me it's to scale, I cannot make that assumption. Okay? So, because we don't know if the triangle is to scale, we can't assume the angle size or even the side length size. The only reason we can do isosceles is because those tick marks. All right, so what about this last one here?
Isosceles.
Isosceles. How did we know it was isosceles?
Tick mark.
Tick marks. Okay. And can I measure it? No. So I can't say it's an isosceles acute, even though it looks like an isosceles acute. I can't say it is. Okay. All right. Number 1. Can I draw an obtuse right triangle?
No.
No. Why not?
Triangle is 180 degrees.
A triangle has 180 degrees. So if I use 90 for one corner, there's only how much left for the other two angles? There's only 90 left, right? And I have to divide that 90 into the other two angles. So there aren't enough degrees in the triangle. Do you think that's the only way I could have worded that?
No.
No, I couldn't. I could even sketch a picture to illustrate it as my explanation. I could say, well, if I have a right angle and then I attach an obtuse angle to that, there's no way I'm going to close that, right? That's not going to close. I'm going to need a fourth side. I'm going to end up being at least a quadrilateral. Okay?
Sure, like square, right?
Huh?
That's a square, right?
A square?
Yeah.
I have to have all 90-degree angles in a square. That can't make a square.
I know.
Yeah. Can't make a square with a right angle and an obtuse angle. I could turn this into a trapezoid if I put a parallel segment across the top there. If I extended that a little further and made it parallel and parallel, I could make it a trapezoid. But I can't make it into a square or a rectangle. All right, number 2, can I draw a right isosceles triangle?
Yeah.
Yeah.
Yes, what would it look like? What sides? There's 3 sides to a right triangle.
The right triangle. The rays of the right angle.
The rays of the right angle. So if I look at my right angle, the 2 rays that come out of my right angle, those would have to be the same. In middle school, we learned we call those the legs of the right triangle. And do you remember what we called this the third side? The hypotenuse. And remember, we learned the hypotenuse has to be the longest side, right? And then your 2 legs are shorter. And in this case, my 2 legs are equal. So I'm not going to like hobble when I walk. My 2 legs are equal. It's unlike when you go to the shoe store and you try on one high heel shoe. Well, some of you may not have ever had that experience. But then you kind of do this funny walk thing because your legs are different sizes, and that's okay. All right, can you draw a right equilateral triangle?
No.
Why not?
One side has to be longer.
Which one has to be longer? The hypotenuse has to be, I didn't finish the word. The hypotenuse has to be longer. The hypotenuse is always longer. Okay? Also, if we remember in an equilateral triangle, I think I skipped over this part up here. I just kind of went right past it. What does it say right here in teeny tiny print?
All equilateral triangles are also equilateral.
So if you have an equilateral triangle, you will also have an equiangular triangle every single time, whether it's marked for you or not. If the three sides are the same, the three angles are the same, and vice versa. If the three angles are marked the same, then you know the three sides are the same. Okay? So you can't have a right triangle being equilateral because that means it would be also equiangular, and we already know you can't have three 90-degree angles in one triangle. How big would the three angles have to be in an equilateral triangle?
Can you repeat the question?
How big does each angle have to be in an equilateral triangle? Acute, but we can tell exactly how big. If there's 180 degrees in the triangle, and equilateral triangles are also equiangular, how big? I heard it? 60, right? So that 60 plus 60 plus 60 makes my 180. Okay? Alright, and then my favorite kind of problems, always, sometime, never problems. A right triangle is isosceles. Always, sometimes, never. Sometimes. Okay? And we had that here, right? We have, well, here's a right isosceles, but here's a right scalene. We can't have a right equilateral, right? We already know that. An obtuse triangle has three obtuse angles? Never. You don't have enough degrees left for that. And an equilateral triangle is isosceles. Oh, I did put A. It is erasable. And an equilateral triangle is isosceles? Always. All right. This used to have a typo on it, and one of the ends was an S, and that was a bad day for me because it spelled a not pretty word. Yeah.